OpenTelemetry has done something really remarkable. It has standardized how teams collect telemetry data across the entire stack. But it has also exposed a new problem. Once all the data is flowing, teams have to decide where does it live? How long can we afford to keep it? And how do we actually query it without rebuilding everything? The monolithic observability platforms were not designed for this kind of a scale, and the bills are proving it. So, what does the next evolution of observability architecture actually look like? That's exactly what we are going to find out in this episode of Cloud Evolution with Eric Tschetter, Chief Architect of Imply. Eric, it's great to have you on the show.
Yeah, thanks for having me. I'm excited to be here.
Same here. Of course, we are going to talk about OpenTelemetry, but this is the first time, if I'm not wrong, I am talking to someone from Imply. So I would love to know just a bit about the company itself. So talk about the company. What do you folks do?
As a company, we've been around for a bit over 10 years now. We started as a commercial entity around an open source project called Apache Druid, which is a distributed column-oriented kind of OLAP engine about fast results, quick queries, and all of that. As we've been working with customers, we've realized they fit kind of one of two kind of patterns. Either we were working with people in the business intelligence space where they're dealing with SQL, doing queries, understanding what's going on in their business, or in the observability and security space where they have a large amount of data they're trying to understand and make sense of telemetry coming from their systems. And with that as a background, we realized that a lot of the evolution and where the business intelligence market is as a whole is actually the exact same trajectory that the observability and security market is going in. And something I like to think about is that, history always repeats itself. There's nothing new under the sun. It's always a repetition of something that's been done. And we kind of see the evolution of business intelligence coming to the observability and security space.
Thank you for that introduction. OpenTelemetry has standardized data collection, but you're saying it's also revealing architectural bottlenecks that were always there. With standardized data now exposing cost, storage, and access decision all at once, where are monolithic observability platforms getting stretched beyond their original design, and what is the quick, immediate, or long-term solution?
I'm not sure I'd go so far as to say that open telemetry itself is. I see it as kind of a harbinger, a precursor to this evolution of the entire data space. And so open telemetry has it has widespread adoption for how people are collecting data, how they're pulling things in for their telemetry. And really what it's done is it's broken the lock-in and the walled gardens that existed beforehand, where you would have been using Logstash. You would have been using the Datadog agent. You would have been using a Splunk forwarder. You would have been grabbing some agent connected to whatever your vertical stack is and pushing data along there. And OpenTelemetry has really come and it's democratized that data acquisition layer. It's democratized the collection of data from a lot of places. Now there's questions about, do you put everything in an open telemetry collector? How much of it should be in your data layer and all of that you can get into. But I think the thing that really for us that it highlights is you have that base layer of data collection from open telemetry. But then where does it go? You're still funneling into some tightly vertically oriented stack that is specifically organized and oriented towards one UI, one way people are interacting with data. And the real thing people want is they want that data to land somewhere, and then they want to use it however they want to use it. Is it a business analyst? Is it a security? Is it for the SIM? Is it for your NOC? Is it for your operations? Is it for your SREs? Who's using the data? There's so many different uses for data. And really what people want is to dump it in one place and use it in all of them. And that's kind of the evolution that we saw in business intelligence. And that's the evolution that I think is coming to this world where open telemetry is, it's just the tip of the iceberg. And there's so much more coming to decouple higher up the stack as well.
Excellent, thank you. And as you rightly mentioned, that it's kind of accelerating the need to decouple observability stack as well. Uh, as telemetry expansion is putting a lot of pressure on tightly coupled tools, what does it actually mean to separate storage, indexing, query, and why is that becoming essential to manage scale and cost? And also, we can look at some of the new workloads like AI workloads are emerging. So, talk about that.
Right. Yeah, no, absolutely. Like AI is also a big part of driving increased telemetry. With AI able to consume data, it also generates data. It generates data faster and consumes data faster. And so it's just accelerating the cycle of what we need to do with data and funneling everything in. But the really, if you think so, let's talk about the security and observability space. You might have your data going into an open telemetry agent, and you might be forwarding that off to Datadog. You forward it to Datadog. The only people who can interact with it are people using the Datadog UI. But that data is useful for your business analysts as well. It's useful for it's useful for your SIM, for your security folks, but it might just be your SREs who are getting it. So, or you might be putting it into Splunk, and people are interacting with it via Splunk, but now other people also want access to that data. Or it might be going into an Elastic stack, and people are interacting with it via Kibana, but they're not. Other teams want that. Now, if you go to business intelligence, which is where I think we draw the parallels, there's a very clean separation between the interaction layer and the data layer. The SQL database has created a very clean separation where you can have your Tableau, you can have your Looker, you can have your Power BI. There's a whole suite of different UIs built to work with data warehouse in the business intelligence world that basically allow for different users and different personas to get value out of that data. And that same thing is exactly how people want to interact with data in the observability and security space as well. They might be using Kibana, they might be using the Splunk UI, they might be using Tableau or Looker. And really, when we get AI in there, AI is just another interaction layer. It's you're outsourcing the interaction with the data to that AI agent, who is then doing all of the work, figuring stuff out, and giving you insights. And so having that one data layer that can allow for each independent team to use their interaction layer, interact with the data how they see fit, and also enable AI, enable the agents to get the answers that they need. That's really the power of the decoupling.
And since you mentioned BI, there is a parallel to how BI has also evolved. The industry moved beyond initial pipeline decoupling towards a shared data layer, which also brings the full point of a centralized warehouse layer that keeps telemetry queryable without locking teams into single platform. Talk a bit about this evolution and the need as well.
It comes back to uh, at the end of the day, humans change much slower than technology. we learn our thing, we learn our workflow. When something's in a business, you have a workflow and you follow it and you run with it. You have some run books, you have things telling you what to do. Changing that is incredibly difficult. But getting the technology, making it so that these run books will work against this data, and these run books will work against this data, and these run books will work against this data, is something that you can align so that you can have one set of data and run everything against it. Now, the thing that we've realized most recently is that with the move towards data lakes, people are saying, oh, just throw all your data in the data lake and it'll be good. But different data types have different access patterns, different things people want to do with it. When you're working with logs, you're doing correlation searches. It's very unstructured. You're looking across the entire log. And as you go to store that data, there's internal structures that you can exploit to actually shrink the data down, make it the smallest possible storage, and then you can implement whatever query languages. So people interact with these things via query languages, not all SQL. There's SPL, KQL, CQL, all sorts of QLs out there that people have. You can take that one chunk of data, and make it accessible via all of these query layers. And that then abstracts however the different teams inside of an organization want to interact with their data from the actual storage of the data. And it allows for that promise of the unified data lake, the unified data storage, and querying it out from whatever a team chooses their preferred tool.
And when you talk about an observability warehouse as kind of a foundational layer that works with, not instead of existing tools, what that does actually mean? How can team retain more data at lower cost and run kind of interactive queries while keeping dashboards, alerts, and workflows unchanged at the same time? In past, we had the whole discussion about data warehouse, data lake. So we don't want to recreate those issues as well.
Yeah, absolutely. And this really gets into the the fundamental learning from the separation in BI is that the query language is the glue between the layers. And in BI has the luxury of only supporting SQL, only supporting SQL. In the security and observability world, there's so many more others, and each of the tools is kind of built around using a specific language, but the ways they interact with the data are fundamentally the same. And so when we talk about reducing the overall cost, what you're looking at is basically saying, okay, when we look at log data, what can we figure out from this structure that shrinks the number of bytes, that makes it smaller, but still queryable? And so one of where this whole thing took us was we've introduced this product called Imply Lumi that has a compression technology where we compress the data while putting it in a form that makes it queryable without decompression. And we've added indexes and other things that basically allow us to store the data in a very tight chunk of bytes, smaller than common storage formats people would put for their logs, but still retain the ability to query, index, do needle in the haystack, find specific points and interact with that data. And this really speaks to when you focus your data layer on a specific type of data, you can exploit the kind of requirements and needs of that data to optimize the experience. And the way that it connects with the end user is really through that query language, through the interaction layer that then enables them to really do whatever it is they want. And I know it sounds magical, but that's fundamentally the way that we integrate with things. We're just a data layer that's implemented the query languages to interact with different UIs.
Once again, thank you. I would also like to talk about Imply Lumi and other solution that you folks have. But before that, can you also talk a bit about the practical impact of decoupling storage from query, the whole decoupling strategy that you are suggesting? How does it address cost complexity and beyond cost? What kind of new use cases does it unlock? Because sometimes, because of the limitation, because of friction, a lot of new use cases cannot get in there. So whether it's longer retention, faster analytics, broader accessibility, or supporting AI driven insights, because that is the hottest discussion these days.
Yes. Well, so retention, like if we go through each of the things you mentioned one by one, you think about retention, what reduces the cost of retention? If it's fewer bytes for the same thing, retention's cheaper because it uses up less space on disk. So when you can make the data smaller, you can retain more for less cost. When in terms of query being aligning with certain use cases and other things, if you have the indexing structures, and I know I'm getting deep into kind of technical weeds here, but if you have the indexing structures to allow you to understand that data without needing to decompress it, you can you can basically skip over data that doesn't matter for your search, that doesn't matter for your query, and only look at what's necessary. And a lot of data tools and a lot of the problems with kind of traditional systems is that they end up looking at everything and throwing away a lot of things. They're like, oh no, I don't care about that. I don't care about that. I don't care about that. Where what you really want is to know you're only looking at things you care about and process them. And so when you can do that, that decreases the amount of CPU required in order to interact with your data. Now, enabling AI and working with AI, one of the big things about AI is that it is going to change the requirements on the data layer, and it is changing the requirements on the data layer. And I'll take this back. I can see you furrowing your brow a little bit. So let me use another metaphor and talk about history repeating itself. AI, you can think of the LLM models, it's fundamentally automating human workflows. It's taking what humans are doing and automating it to a certain extent. Now, this was done in the past with manufacturing automation. There were people on an assembly line, and robots came in and started replacing things on the assembly line. Do we still have the assembly line today? Yes, we do. Does it look the same way that it did back then? No, it doesn't. It's changed. The shape of it has changed. And so if we look at how manufacturing automation impacted the assembly line, I believe that's actually a metaphor, a historical metaphor for how AI and LLMs are going to impact the interaction with data and how data works. And so manufacturing automation, assembly lines are now built around placing robots, about how robots are connected, about the things that they can do. And the output of any one factory has increased so much that there's been a lot of knock-on effects on supply chain because they have to get a whole lot more material in order to generate the output for that one automated factory. And that's exactly what's going to happen in the data world. The data platform is fundamentally the assembly line. Is it going to go away? No, because you have to store your data. You have to have it there. You have to have it interactive. But as AI interacts more with data, it's going to consume more data. It's going to generate more data. That's going to have knock-on effects on all of the data collection, on the amount of data that's coming in, which is then going to put a lot of pressure on cost and storage, which requires you to have the lowest possible unit cost for storing that one bit of data, but also the structures that enable the AI to interact with it as fast as possible to get you your results.
Very well said. Thank you. And I also like your analogy of manufacture, especially assembly line, because there is a lot of FUD against AI these days as well. Some is valid and some is just FUD, as we have seen in past as well. So I actually like that code very much. Now, can you talk about what kind of solutions is Imply offering? Because we are talking about problem areas, we are talking about solutions, but what are you folks doing to enable organizations to bring that, whether it's business intelligence, observability, their own mission goal together?
Yeah, so we the Imply Lumi product is a data layer that decouples things. We, as a product, we are focusing on the data layer, and it's specifically a log-oriented data layer right now, where I mentioned we have compression technology that can compress the data significantly while maintaining the structure so that it's both compressed and queryable at the same time, which is one of the things that eludes other things. Like general purpose compression, you have to decompress before you actually can query it, where our compression maintains the queryability without decompression. And then we've integrated and implemented different query languages to connect to other ecosystems. And so our thing is, as far like in this decoupled world, we don't necessarily need to have an opinion about what the end user is actually using to interact with their data. Are they using an AI agent? Are they using Splunk? Are they using Kibana? That's not something we have to decide as long as we can enable all of those options. And so that's been our focus. And so we are just very hyper focused on what can we do to reduce the unit cost of the storage of logs, make the queries as efficient as possible, and connect up with the query languages, implement the query languages that enable all of the ecosystems that people have already adopted so that they don't have to change their workflow. They can continue to get the value from their existing workflow out of that data.
Eric, thank you so much for joining me and walking us through this topic. The core idea here is powerful. As hotel drives telemetry volume higher, the architecture has to evolve. And separating where observability data is stored from how it is queried isn't just a cost play. It is how teams actually get control and flexibility at a scale. Thank you so much for your insights, and I really look forward to the next conversation.
Yeah, thank you.
And for those watching, if you're feeling the pressure of growing telemetry cost and limited data access, make sure to check out Imply and what they're building in the observability space. Thanks for watching, and I see you in the next video.